Alright, level 2, question 5. The diagram shows 4 blocks of flats, and the points A, B, C, D represent the foot of the 4 blocks on the ground level. So there are 4 blocks, A, B, C, D, and these all represent the foot or the bottom of the block at ground level. These are all the bottom. It is given that B is due east of A, so that tells me that this is a perfect east, right? So that actually tells me that if I have a north right here, right, that this would be a perfect 90 degrees. That's what it tells me. It's due east. Yeah. So once again, it's north, south, east, and west. Okay. Now the bearing of A from C is 220. So they already told us of A from C. So let's say if you have a north at C, the bearing is 220. It's very convenient. They've marked it out. ABC angle is 60 degrees, right? ABC 60. And BC is 65 meters. So BC 65 meters. BD 90 meters. CD 55 meters. Cool. Calculate angle BAC, which is this. So the first thing we should do is really try to note out the angle we're trying to find. And it's not that straightforward at first, because when I first looked at this question, I was like, wow, I can't find this angle, and I know this length and this angle is, but it's not that easy. But one thing I could do really is, quite conveniently, since this is 220, I could find this angle, right? I could find this angle, and so I can say that, and I can call this, let's call this point N1, right? And so N1CA, I can say that N1CA, the angle, is basically 360 degrees minus 220, which is 140. So this 140 angles at a point. And then, you see, I put a north here, and that tells me that the norths are always parallel. That's a very useful thing to use in bearings questions. Norths are always parallel. So that tells me that this is 180 minus 40 by interior angles. So let's call this N2. So N2AC is basically 180 minus 140. This interior angles. Cool. And so that's very useful. This is 40 degrees. And since this is perfectly due east, this is 90 degrees, so I can just take 90 minus 40 and I found my angle. So this really is 50 degrees, which is 90 minus 40. So N2AB, I'm just going to say, equals to 90 minus 40, 50 degrees. And for part B now, they're asking for the distance AC. So since I have this angle now, it's quite convenient because I have this angle, I have this length, and I have this angle and I have this length. So I can find this length using sine rule. Yep. So this I, if I can just put a double I. So this is kind of the triangle, what it looks like. ABC. And this is 60, this is 50, and this is 65 meters. Right, so that's kind of convenient. So we can say this angle goes with this side, and this angle goes with this side. And so we can say that sine 50 over 65 equals to sine 60 over AC. We cross multiply, and we see that AC times sine 50 equals to 65 times sine 60. AC, divide both sides by sine 50, therefore is this, right? And we key all of that into a calculator, and we get 73.48. Now this is length, right, in meters, so we can say this in meters. It's exact, or we can put to 3 SF. And that's how we do it. Okay, now let's go for angle CBD. So AC is 73.48, so let's just write it down. AC is 73.48 meters. Okay. In case we need it later. CBD, so CBD, let's just note out that angle. I'm trying to find that angle right now. And can we find it? The interesting thing is that for this triangle, right, that this angle is a part of, so every time they ask you for something, look at what it's a part of. So it's a part of this. And you know all three sides. So actually we can use cosine rule, right? We can actually use cosine rule. And cosine rule will tell us, okay, I'm going to do it at the side right now. So cosine rule will tell us for this triangle, right? This is the angle we're trying to find. This is CDB. And we're going to say 55 square, or A square, equals to B square plus C square minus 2B C cosine, the angle in between, cosine CBD. Right? And this is what we're trying to find. So we can just kind of try to simplify all of this first, and so that gives us over here, this is 3025 equals to, and 65 square gives me 4225, and 90 square gives me 8100, and then we subtract away, and this is if a 2 times 65 times 90 gives me this number multiplied by cosine CBD. And then we can just do it like we know how to. So we move, we subtract both sides like this. The negative sign still stays with this. Okay. Right, and then we continue solving. This is negative 9300. And so we need to divide both sides by negative 11700 to find cosine CBD. Okay, and so angle CBD is therefore cosine inverse of this. And therefore it is 37.36 degrees if it was 4SF, or if I put a 1 dp for degrees, as we usually do, 37.4. Right, so let's write that in. This is actually 37.4 degrees. Cool. Right now, it says the bearing of D from B. So let's try to find the bearing of D from B. So we have to introduce yet another north here. Okay. And so let's call this N3, since we have N1 and N2 already. And of D from B is actually this tiny little angle over here. Yeah. And let's try to find it. And so it's really convenient. We always seem to use the fact that all the norths are parallel. So let's look. If we can find this little angle here, then we can take 37.4, subtract, if we can find, then we can take 37.4, subtract this angle, and we can find this little angle here. And look at this. These two norths are parallel. So can we find this angle? If we can find this angle, then by interior angles, we can find this angle. Right? Because to find this angle, we can actually maybe take 220, subtract away this angle. And so that's kind of convenient, because we can say ACB. And so, wow, I need to find space. Okay, let's do part 4. Okay, we should just continue over here since it's still part A. I can say angle ACB, if you look to the top here, ACB, is simply just 180 minus 50 minus 60 will give me this angle. Right. So I can say it's 180 minus 50 minus 60, which is 70 degrees. So that's very helpful, because I can now write this as 70 degrees, and then this will therefore be simply 220 minus away 70, and so I can say N1CB. So I'm going to say N1CB equals to 220 subtract away 70 degrees, which is 150. Am I right? Yep. Okay. So this is 150. So therefore, CBN3, or this little angle here, it must be 30 degrees. It must be 180 minus 150 by interior angles. So I'm going to say CBN3 by interior angles is going to be minus away 150. Right? And so since this is 30, then 37.4, or I can use the over here 37.36. So I can say the angle that I want, which is N3BD, is simply 37.36. If I'm just using here before rounding up, subtract away 30 degrees, 7.36 degrees, and I just put the 1 dp as we usually do for angles. But we're actually not done, because if you look at the question, it says it's the bearing. So it's actually a bearing. The bearings, we can't put it this way. We have to put a 0, 0, right? It has to be 3 digits, and maybe after decimal place, a 4th digit. Yeah. So now we're done. Okay, part B. A boy walks directly from C to A. So this guy walks from C to A, and calculate the distance he has walked if he is closest to B. So as he is walking from C to A, he's going to be closest to B at some point. And to solve this, we basically drop a perpendicular, right? He's closest when he is line of sight is exactly perpendicular to B. So he will be here when he is closest to B. Yep. And calculate the distance he has walked. So they're trying to ask you that he walks from C to A, and this is the distance he has walked when he reaches this point when he is closest to B. So this is the distance we are looking for. Right, this is 90 degrees, this must also be 90 degrees. So let's try to dissect. We can see that this is actually 70 degrees. So it's a bit messy. I'm just going to redraw. Okay, so part B, I'm going to do it here. I'm going to redraw the triangle. C. Okay, and this one, I like to do this. Let's call this X. Alright, this point is X. So C, and this is X, and this is B. This is this. And we know already that we solved this is 70. Right? And we know that this is 65. And we know this is 90 degrees. So really, whenever you see a right angle triangle, think if you can use the sine, cosine, tangent, the Tua Kaso. Yeah. And we're looking for this. So we can say this is basically, for this angle, this is my adjacent. This is my opposite. This is my hypotenuse. So I can say, if I want my adjacent, I can say cosine 70 degrees is cx adjacent over hypotenuse. And there you go, like, you solved it very, very easily. Yep. Okay. Now let's get to the last part. If the block of flats at C is 40 meters high, okay, and find the angle of depression of B from the top of the building. Okay, and so for this one, let me just do a quick recap of angle of depression. So let's say you are let's say you're on the ground. Okay, let's call you put in X right here, and let's say there is some building, and there's another person who is looking out over here, right? If you look straight ahead, he would just, he won't look at you. But if he looks down, then he has to look down to look at you, and this angle is the angle of depression. How much he has to look down so that he can look at you. So in this case, at block, it says that the block of flats at C is 40 meters high, and so this, let's say at C, this is at C, and this is 40 meters high. And from C, he is looking at C. Now really, this block of flats is pointing out of the page. It's actually standing on top of your paper. You can't really put it on the paper, right? It's actually in the third dimension. It's not, yeah, it's actually in the third dimension. It's as if like you're putting a pencil, like, sticking out from your paper at C. And you want to calculate the angle of depression of B from the top of this building. So what it looks like is, this is at B. You're trying to find the angle of depression. And the distance from C to B along the ground is 65 meters. So this is actually 65 meters. Yep. And so to solve this, I'm going to do part C here now, is that, can you see that this, because this sticks up from the ground, right? This is 90 degrees. It's always 90 degrees. We can find this because we know the adjacent and we know the opposite. So we can say, and I'm going to call this C high, because it's basically still at point C, just high above point C. So we can say the angle C high BC, right? And the tangent of this angle, which is this angle, C high BC, is basically opposite over adjacent. The good news is that if you can find this angle, then we found our angle of depression, because these two lines are always horizontal and they are therefore parallel, and so they are equal. This and this are equal by alternate angles. This is a very, very common way to solve for angle of depression. Tangent inverse 40 over 65, right? And so let's just find that, and that is 31.61 degrees if I put the 4SF. And then I can say my angle of depression is also equals to 31.61 degrees by alternate angles, which is 31.6 degrees if I put to 1 dp. There we go. Just going to draw a border here. And that's it for this question. There's everything inside.